Now today's video just extends on the last one just a little bit. We're going to look at parallel and perpendicular lines. I'm going to use this line here as our example, y equals 2x on 3 plus 1. Now obviously a quick way to graph that is going to be, I go to the, because it's one little y, I can go to the number by itself, and that tells me where it cuts the y-axis. Now the number in front of x, which is 2/3, tells me from this point I travel up 2 places, across 3 places to find where the line is again. Travel up 2, across 3, there's the next point on the line, or another point on the line. That line there is the line y equals 2x on 3 plus 1. Now you're going to get some questions that will ask you to do things like come up with the equation of a line that is parallel to this one. Well, for it to be parallel, it just has to have the same gradient. So there's a parallel line, there's another parallel line. They have exactly the same gradient, so for the parallel line one, it's just going to be y is equal to the same situation here, 2x on 3. But each of these parallel lines are just cutting different values on the y-axis. So you could put on here anything you want, plus 2, plus 7, plus -8. It doesn't really matter. If you're asked to come up with an equation of a line parallel to this, just keep the 2/3 in front of x the same, and then any number on the end that you want. Now, if you're going to do a perpendicular one, you've got to do something slightly different. So with our perpendicular, let me just give myself a little bit of room here. Now, for lines that are perpendicular, there we go. Perpendicular just means they meet at a right angle. You just need to know something. The gradient of the original line that you're looking at, if I just call it M1, gradient of the first line, and for the second line, its gradient is M2. When lines are perpendicular, multiply their gradients together, you'll get -1. If you're interested in seeing why, I can show you in class one day, but just for now, just know the gradients times together will be -1. So our original line had a gradient of 2/3. So to find the gradient of the second line, we just times them together to get -1. Now, to get M2 on its own, that's just going to be, let's see, I've got -1 here originally. My multiply by 2 comes over to become divide by 2. My divide by 3 comes over to become multiply by 3. That's going to be, so -3 on 2 will be the gradient of the line, any line that's perpendicular. So once again, if I want its equation, it's going to be y is equal to -3x on 2 with any constant added on the end that you want. And they're the two type of questions you're going to come across. Lines parallel, keep the gradient the same. Lines are perpendicular, make sure the gradients times together give -1. By the way, a quick and easy way of doing this, we call this the negative reciprocal. Go to your original line, find its gradient, in this case 2 on 3, turn it upside down, 3 on 2, and make it the opposite. So we have a positive gradient here, make it a negative gradient here. Or conversely, if you had a negative gradient here, when you turn it upside down, you make a positive gradient here. And there's your parallel and perpendicular line questions.